Hi, to all my esteemed viewers, this is Tutor Buxton. I would like to welcome you to this channel where we get to learn estimation. Today, I would like us to go straight into estimation or measurement of quantities of steel for the substructure columns. First of all, for you to go about that, go to your plan, the foundation plan, layout plan that you have. Identify the number of columns that you have, the specific types, and then you categorize them. When doing that, you're going to make what you call a column schedule. From the column schedule, I would like us to just have a few rows of items. And I would like us to copy exact item that we did in our previous session. For those getting this to this channel for the first time, I would urge you that there are going to be catch-up videos for this particular session at the description point, whereby you can get to learn the rest of the items we've covered. So looking straight into what we are expected to do, in the previous sessions we got to outline what we call the column schedule. So that is the column schedule that I'd like us to continue with, and it was basically an identification of the number of columns that we have and their respective sizes in terms of the length and the width, plus the number of those columns which are available on the plan as they have been drawn on the plan layout. So once we've understood that, then what we go do straight away is first of all, we are going to start with the column C1. From the column C1, we go to the details. Just scroll down, get the details where that column has been given. So this is the detail, and this detail is giving you the number of bars and so on. So first and foremost, I would like us to start with the main bars. The main bars are the ones that you can see from this particular column. It's 8 to 16. So from the 8 to 16, those are the ones we start with. So as usual, look at the ID. ID is basically giving you that is T16. Now that is the identification of that particular bar. And of course, because we are starting with the column C1, we don't need to write 8 to 16 stroke 01, because in this case, we are sure that we are not coming back to column C1. So after column C1, then you go to column C2 and so on. So this is T16. So the next part is the diameter. So I would also like to just teach you just a little hint here. I would like to freeze this pen so that I don't have to scroll upwards, so that I see which item or the column I'm dealing with. So if you want to do that, you go to the page layout. From the page layout, actually it's the view tab. From the view tab, you go to freeze panes. Then you can talk about freezing the top pane. Actually, it's talk on that. Then you freeze the top row. So I'll have to. So you select that particular row that you need. Then go to the view tab, freeze panes. Then you you click on freeze the top pane. So once you do that, you'll be able to have that top pane stuck at that point. Therefore, you don't need to keep going back and forth. So once that is understood, so we've started with the main bar, 8 to 16, and that is what my cursor is moving on. So this is the diameter is 16. The number we should be talking about, the number of bars on one column, and then we multiply by the number of columns. So it's 8 in number for one column, and then you multiply by the number of columns. The number of columns that we have for column C1. So column C1, they are 12 in number. Okay, right. So they are 12. That is what we counted from our very first schedule when we got to when we were doing the column, the concrete for the columns. So once you have that, and of course you can always just count them once again when you need to know how many they are. So for instance, in this case they are 11. You can always start with the lower one. So you can see at the bottom those are 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so those are 12 columns for column C1. So 12 times the number of bars on just one column. Then the length, or you can call it the height, whichever the case that you like to refer it to. So what we do now is the minimum height that should be used, that is from the top of the base to the top of the ground floor level slab, is 1.5. Okay, so you'll use the one, or you can start from the top. We take 1.146. so this height normally some engineers don't give it, so it's you to assume what to allow in case for the purpose or the bar that is overlapping. Okay, because you realize that when you're going to connect to the superstructure, for the superstructure bar, then it won't be allowing, or you won't be having that bar starting from the surface of the ground floor slab without any connection. So there is always an overlap between those two given bars. Okay, the top, the one that is going for the superstructure, and the one that is emanating from the substructure level. So if I'll just zoom this, you will notice that the bar that I'm talking about is here. All right, so we are going to use a height of 1.146. That is at the top, and then we'll add the 1.5, which is the minimum that should be used here. So after the 1.5, then we also allow some height for the foundation column base. So for the foundation column base, you can see it's 450. Yes, and then there is a part of it that is bending at the bottom of that particular base. All right, so you can't actually tell actually for this case what I would always advise that you do, you can take the whole of it, which is 450, the whole of it, but then you subtract what we call the cover. So you take the full 450 and then you subtract the cover. Cover is 50, so the 450 minus 50 should be giving you 400. So that is 0.4. So for the 0.4, you shall have reached just the straight bar, but then you've not included for the bend. All right, so for the bend in relation to the 2 meters, 2 meters is a bit bigger, but because it's not given, that that length is not provided, then it's therefore for you to decide what to use. All right, so in this case, if it's 2000 and our column is 200, all right, then definitely you would prefer that you have it going beyond the 200. So in this case, I can advise that you use a length of a bend of about 400 millimeters. So you can add another 0.4. So not unless it's provided, then you can always assume some reasonable length for the bend. But of course, the most important thing is that you're taking note of the overlap, which is length that should also be included, and you're also taking note of that height or that length between top of the slab to the top of the foundation column base. And then you're also appreciating that there is part of it within the column base, and then there is a bend. All right, so as long as you're going to assume those particular parts, especially those that are not given consistently, then you should not worry about any other item. So we have the length. In that case, we've got it to be 3.446, and then we go to the total length. Total length, as usual, we'll just copy, or we'll just take the number of the length of one of the bars, and then you multiply by the number of the bars that you have. So the total length comes to that. Conversion factor is still 162, and then kgs that we are having here, we are going to maintain this formula. For the sake of my new members that are getting this video for the first time, the formula is d squared times the total length divided by 162. So if in case you are new, you are wondering how that formula is coming about, that is the formula which you use to get the kgs for the bars. Alright, d squared times the total length divided by 162. So we've talked about that, and as usual, we prefer that we finish with one bar or with one column, and then we proceed to the next column. So the next item that we'd like us to use, or the next bar I would like us to calculate its weight, is the T8, the so-called the links. Okay, so the links are going to be tied at the to the main bars. All right, so those are the links. So for those particular links, the diameter, you can see them here, T8 02 200. So it means the bar is T8, diameter is 8 millimeters. All right, these are the ones that I'm talking about. We have 02 200 and 02M 200. So it's T8, diameter is 8 millimeters. The number of the bars is what we need to calculate as well. So the distance that we need to use, the length that we need to use for us to get the interval and the number of bars is just what is within, because the overlap will be having its links considered to the superstructure level. So we only need to consider what we have here. Alright, so in that case, we'll take, you can even notice the span that is provided here along the arrow. Okay, so we'll take the 1.5 meters and then we divide by 0.2 and add 1. Right, so that is what we are finding there. So the length of 1 is what we need to calculate next. So for us to calculate the length of one of the bars, this is what we are supposed to do. So first of all, this is how the item or the column is looking like. So you check on the details so that you find out how the length of that particular link is going to be calculated. So what we do, we have the detail. This is the column C1, and the detail is typical from the substructure to the superstructure level. So how do you go about that? So we need to calculate that length. First of all, as usual, consider what the cover is. So you will go to the sidebar and find the details of what you have in terms of the cover. So looking at this cover to reinforcement, also just to reiterate the reason why we need cover and what it means. Cover just prevents the column, the reinforcement bars from the exposure that might lead them into corrosion and eventually compromise their structural strength. So the cover bases is 50, the columns is 40. Right, so the columns, we have a cover of 40. So once you've known that, then we get back to our Excel sheet and continue with our calculation. So this is it now. First of all, the column is 500 by 200. So is equals to, we need to get the length. Now the length is going to be, okay, for the longer side, whichever way you wish to refer it to. So it's 500, so that is 0.5, and then we subtract 0.5 minus 0.5 minus the cover. So cover is 0.04 times 2, that is 40 in meters. So 0.04 times 2, that is for the longer side. And then okay, so we can bracket that to show that we have what we call the length, and then we add on the shorter side, it's 0.2, and then we subtract also 0.04 times 2. All right, so what we've done, we've just calculated 2 over 2 sides. Okay, so we need to get the sum of these. We multiply by 2, just the same way you'll get the perimeter of a rectangle. That's what we are doing. So after that, now we have a complete length, but then we've not considered what we call the hooks. If you look at the end here, we have the hooks on either side. Alright, so for the hooks, I would use a length of 50 millimeters, so 0.05 times 2. Alright, so that is the length of the hook that you'd use. 50 millimeters is just sufficient. So what we've done, we've got the column as it is. From the column, we subtracted what we call the covers, which I've just explained the essence of having the cover. So you take the total, which is 500, minus the cover on either side, cover to the top and the bottom. So that is 0.04 times 2. Then you add to the shorter side 0.2, then you subtract cover as well. Then you also add, then you multiply that by 2 so that you have a complete perimeter. Alright, then you add the hooks. Hooks is how those bars are going to be bent closing up at that particular point. So that is 0.05 times 2, right, is equals to 1.18 meters. So for us to get the total length is now the length of one piece times the number of the bars, which I'm also realizing here that I didn't multiply by 12, so I need to do the same, right? That is the essence of doing your work procedurally. You can easily spot at a point where you've messed up or you've left something out. So the 1.5 was just one of them, but then there are 12 number of columns of the same size, so they are going to be 112. For that matter, total length is therefore equal to a length of one link times the total number of links that we have. Constant is still 162, while the kgs also maintains in terms of the formula is still the same. So once we have that, then straight away we go to column C2. Column C2, as usual, the first step that you have to take note of is for you to calculate, identify the main bar. So let's first identify where that, this is C1, I'm looking for, this is C3, I'm looking for C2. Alright, so let's see where C2 is. So looking into this, where is it? C2 is here. So we have column C2 at this particular point. I'll just zoom it in properly so that you are able to follow up and see what we are talking about. So this is where it is, and I would like us to take it on. Okay, I don't know, it's doing that. So I'd like us to measure it. So the first one, you can see here, it's 12 to 20, 01. So these are the main bars. So the processes all we have done for the previous bar are going to be maintained. And you notice that these are C2, both of them. So, C2, all of them are having typical details in terms of the sizes of the bars. So we'll take it on. So this is T20. T20, as usual, identify the bar T20, right? One shouldn't be there. The diameter of the bar is 20, and then the number of the bars. So for the number of the bars, I would like to copy the formula that we have here, paste it here, because the height in which those bars are going to be spread, actually no, that's not the case. I'm talking about not the links, I'm talking about this one here. So that's what the one I copy. Alright, so in this case they are 12, not 8. Right, so there are 12 bars, 12 to 20, right, times the number of columns which you have. Column C2 are only 2, which you can confirm from the plan. Column C2, when you count them from the plan, they are only 2 on this bigger base, that is CB2, only 2 of them on the plan. Just take a minute, just confirm with me if in case there is any that are missing out. They are only 2. So once you've confirmed that, then you multiply by the number of the reinforcement bars in one column times 2 columns. So that is 24. Then how do you get the length? The length is going to remain the same for what we've done for the previous column. So just copy the one that we've got, which is the 1.146, serving as the overlap. You can see that for 1146 plus 1.5, which is the minimum that you're using there, plus 0.4 plus 0.4. So once you have that, then you get the total length. How do you go about that? Total length should be length of 1 times the number of bars that you have straight away. Alright? So that is 24 times the length. Once you have that, constant is still remaining to be the same, and the formula is still remaining to be the same. Perfect. So we go to, this was the number, so that is complete. We go to T8. For the T8, operation remains the same. So not unless you find that the column sizes are different. That is when you are going to have different length and so on. So the diameter is 8. Just fill in the items. The number of the bars, let's see what is going to be. So the length is same, 1.5 divided by 0.2. You can also still see that the interval is 200 plus 1, then times, now we are multiplying by 2. We only have 2 columns. Then how do you go about the length? So the length, we'll copy the formula that you have above, but then now we need to confirm what is the size of this particular column C2. It's 500 by 200. That means we still have the same calculations that we've done above to be repeated for the column C2 lengths. So 0.5 minus, that is the cover, and then we do the same, the width is 200, multiply by 2, then we add 0.05 times 2, which is the hook. Alright, that is maintained. Then we go to the total length. Formula is still there. The length of 1 times what we call the number of the bars. Right? Then length conversion constant is still 162. The formula is still maintained. So straight away we've learned that as well. Then we go to the other column. And that is column C3. Column C3, I can see it's just close here. So here it is. Alright. So the main bars, look at that, 12 T16. So the main bar is T16. The diameter is 16. The number is what we need to find out. For each column, there are 12. Then for you to know how many columns are there, get back to the plan and confirm. Alright, column C3. So I'll zoom it out so that you are also able to help me count. Looking at this in a very quick check, C3 we only have 2. There are only 2 number for C3. Get back to our detail because that is what we are using for our calculation. I bring in my Excel, so 12 for 1 column, then times 2 columns. Alright, so those are 24 bars. The length is going to remain the same, alright, because the height is typical all across. Okay, then the total length formula is 1. Length of 1 times the length, the number of the bars. 162 is the same here. Kgs that we have is now going to be 130. Then we go to the links for that particular bar, that is T8. Alright, so after the T8, diameter of the bar, diameter is 8. Number of the bars is equals to, so we copy what we have here, copy that, bring it there. Right, the interval is going to remain the same. Actually, you can see from what we have there. Then we add 1 and multiply by 2. We only have 2 columns of that size. Length in this case, we also copy that, bring it here. Then that brings us to the same. Okay, we need to confirm if at all the size is still the same. So I'll go to column C3. So you can see column C3, it's still 500 by 200. So everything that we've done is remaining to be the same. So once you've noticed that, then you proceed with your calculation, and this is how it is. Length of 1 times the number of bars, and then constant is still 162, and then the formula is still the same. Alright, so we have all the columns, all the bars for all the columns indicated. So I'll just widen my screen a bit so that we check out what we are missing. So we can now unfreeze. We can now unfreeze the panes which we froze. So unfreeze that so that we are able to see what is left. So we've done the strip footing, the reinforcement for the strip footing. We've also done the reinforcement for column bases, stub columns, so the foundation columns is what we were covering. Alright, then there is a little bit left for the ground beams, and then we'll call it done for the reinforcement bars. Alright, so let's see what we have for the ground beams. Get to the details. Detail for the ground beam, it's here. Alright, and the ground beam, the reinforcement detail is also drawn at the side. So the ground beam was 300 times 200 in terms of the size. For the bars that we have, it's 300, 2T12 at the top, then we also have 2T12 at the bottom, and we have a link of T8. So as usual, the way we've conducted the other ones, we'll identify the bar. That is the first line of identification. Identify the bars. So the bar that we have is T12, right? T12. Then the next thing is for you to identify the diameter. The diameter is 12. Alright? Once you've known that, then get the number of the bars. You notice that we only have 1, 2, 2 at the bottom, 2 at the top. That gives us a total of 4 bars. Alright, so those are 4 bars. Then we get on and calculate what we call the length. Alright, so what is the length of each of the bars that are provided there? For us to get the length, we had calculated when we were doing the concrete volume for the ground beams, we got the length. Alright, so this was the length, the width, the diameter, and so on. And the length is 14.6. Okay, so 14.6, I'll just equate it to that one there, 14.6 for the length of each bar. Alright, and as usual for the beams, I would always suggest that you always give an allowance of about 20, 25 or to 30 to cater for the overlap, because you notice that because you are laying the bars for the beam, there is going to be an overlap that has not been drawn on that particular section. So while you stick to it, then you realize that you're going to be having a lower figure than what is actually going to be used. So it's always safer that you give an allowance for the overlap at your estimation level, because that is the exact thing that is done, and you don't need to have a lower figure. And of course that percentage range allowance is always given depending on the quantity of the concrete that you have, alright, or the quantity of the land that you have. If you have a bigger beam or something, then you're going to allow a smaller percentage, taking note that the maintenance of percentage on a higher value with the increasing quantity, then you're going to have a resultant bigger quantity for an allowance instead. Alright, so that is 14.6, but then I would like to give an allowance of 20%, so that is 1.2, so that in one bar you're giving it allowance already. Then as usual, get the total length. And how is that come about? The number times the length of 1. Alright, that gives us that. Then this is 162, and the formula is remaining the same. Okay, diameter squared times the total length over 162. Then I would like us to get the lengths for the beams. Diameter is 8. Alright. After the diameter, then we get the number. So the number is equals to the length of 1, you've just got it above there, and then you divide by the interval. Alright, it's T8 stroke 02, which is the bar mark. Of course, T8 is the diameter, then stroke or dash 200, meaning the interval is 200. So you divide by 0.2, then you can add 1. Alright, and of course that is now the total number that you have for those particular links. Alright, so how do you go about the total? No, this is the length. So the length will maintain the same way we calculated for the other ones, and we see now what exactly we need to use. So in this case, it's 300 by 200. Alright, 300 by 200. So the longer side is 0.3, not 0.5, minus the cover. So as usual, get to the notes and see what you have for your covers, right? So there is this point where they are indicated. Beams are having a cover of 25 millimeters. So you notice the covers are changing from one point to the other. So the beam cover is 25, so that is not 40 anymore. So it's 0.025 times 2. Then you add now for the longer side, the shorter side, it was 300 by 200, so it's still 200, but then this one is 25. Alright, and then times 2 as well, times 2, and then we add the hooks also 50 millimeters, so that is 0.05 times 2. Okay, then this formula is going to remain the same, and it's length of 1 times the total number that you have. This is still 162, and the formula is still remaining to be the same for calculation of the weight. Alright, so from here, the only reinforcement that is left, but not a reinforcement bar, is what we do about the BRC. And BRC is only laid for the foundation ground floor slab. So looking at all the reinforcement concrete elements, we have done strip footing, we have done column bases, we've done stab columns of the foundation columns, and we've also done for the ground beams. Alright, so that stated, we'll go straight and make our description. Alright, so this is R, so this item R. So first of all, I always prefer that you start with the smaller one, which is now T8. So I'll give a summary. So I can give a reinforcement summary. So from our summary, what you do, just do T8. Of course, it's not a requirement that you have to list that these, for example, you don't have to specify that strip footing, you have this quantity, columns, you have this quantity, unless otherwise. The rule which we had given in full stated that you can only describe in terms of identification of the bars that you have. Alright, you can categorize them depending on the diameter, not necessarily on the areas where they are going to be used. That is what the standard methods of measurement is stating. So T8 is equals to, so we sum, right? We start from the top, that is T10, moving on. Alright, it appears T8, the first one is that. Then we add another one is that. Then another one is here. Then another one is here. So that is the total for our T8. Then we do T10. We do the same, equal sign, just be keen while following up on each of them one by one. So it's that first one, and then we add, that is the second one. Moving on keenly, and it's only, there are only those two. And then we go to T12. Do we have T12? Alright, so T12, I'll start. that is the first, that is the second, and seemingly we only have that. No, there is another one here. So we have those three. So from T12 we go to T16, so just maintain that order and sum them up keenly. Alright, so T16 is the next. T16 we have that, then we add that one, then we add the third. Alright, then the next slot for T16 is here, then we have that one, then we have that one, so all the way, no, that's a repetition, yes, that one, that is 51, then we have that one. You can click on that to confirm if at all there is any that you're leaving out. And of course there is this that needs to be added there, and also we have that one there, and that is all. So can just confirm so that you haven't, make sure you haven't skipped any of them. 16, we've also included all these other ones plus the last one of them there, and that is it. Then we go to T20, so that is how to do that work properly. T20, let's see where to start. From the top there is none, there is one here, this one for 150. Moving on slowly and keenly, the other one is 204, and it's the last. Do we have anything to do with T25? No. T30? No. So that is the summary, right? Oh, good. So we go to, so just the description is very simple. T16 bars, so just state it straight away. You don't have to have so many items indicated. So actually we start with T08. I always like to be very orderly. So T08 kgs for that is 95. Okay, of course you round it up, so that is 95 kgs. So this is S, and the bar is T10. Okay, T10 kg. What's the kg for the T10? T10 is 71. Okay, then you go to T item T, so that is T16, also still in kg. And for the T16 the weight, actually I've skipped T12, I should keep to the orderliness. So T12, T12 the weight is 227, right? 227. This is U, and this is T16. T16 is 1863. 1863 kgs. Now it should be here, 1863 kgs, not here. And this is kg. This is item V, and that is T20, which is the last one, kg, and the weight is going to be 355. So exactly that is what is expected of you. As usual, we keep in track, or we keep editing our document properly. So these are excavations, A, B, C, D, E, F, G, H, and so on. And you can see this one is overlapping, so I will copy this particular part. All right, and I want it to be here so that we have our document properly added. So I would like to delete the other items, so just highlight that, and then you can deselect part of it, and then you delete what you don't want, because you understand that we have our formula on the other side. If we include the items that shouldn't be included, then we can have different sums instead of what we expect. So is equals to sum. If you also need to understand this, is equals to, then you type sum, double click, and then you add what we have here. Right? Of course, you'll make use of that when you have now the rates, but for now it's this is now carried to collection, and then this now a different page altogether. So for every different page you need to start afresh in terms of your alphabet. Alright, so that is how to go about the same. Alright, so carried to collection, we have that one here. Then the sum should be ending. This is now not F3, that sum should be ending from that page. Alright, then now at the bottom here we have what we call the collection. Alright, so for the collection you should have the items that you are going to carry. So this is A, and then this is B. Alright, so for this one you can say brought forward from page, and then brought forward from above. Alright, so you need to indicate which page is the first one coming from. So you can have a preview and you see which page that is going to be, and you can notice that you don't have the pages indicated here, so that means you need to include them. So how do you insert the pages? So you already have that, the view tab, then you go to the page layout tab. From the page layout tab you can go to footer. Alright, so from this point you can I always like indicating now the first prefix of the section, that is builder's work, then hash or stroke. Alright, builder's work stroke, and then you write and. Alright, then you do this, right, page close. So when you do that, just click outside to confirm what you have. So you can see it's coming with a prefix, builder's work, then the page is following. If you didn't catch that up, just go to the footer, go to the view tab, page layout, type that item at the footer. Whenever you want it, you can have it on the side, on either side. So builder's work, stroke, and page, then you close that. Very easy, I'm sure about that. So the first one is going to be from page, builder's work, stroke 1. So that is where we have the first item. Then at so this is the collection. From the collection we have at the end we have what we call amount. Alright, amount. So can have that very simple collection. Then now the first one to be brought forward is that, not that one, it's yeah, it's going to be that one. And then brought forward from above is just what you've just added there, and for you to make your work even look neater, so at this point you can write total. Actually you can still just copy that, and you can bring it here, and then you talk about total for substructures, carried to summary of the section, of course. Then now this is the total only for these two items we've done, And of course, this even gives us an easy time, so we can just make this particular bar. Go to format cells so that you have it all formatted properly in prior. So you have that. Okay, once you've stated okay, then it goes away. So we have that. You can make this to be bold. So of course there are a few items that we need to cover also under the substructures, including we'll carry on from reinforcement, fabric reinforcement, the substructure walls, and so on. But then you can just insert those items within the upper part of what you've already edited. So that's how your document is supposed to be looking like. So in our next session, we're going to carry on with the next the few items that are left under the substructures. So that should bring us to the end of our session that we needed to cover today, and I want to appreciate you so much, and I'm confident that you are learning a day in and day out. For every concern, every inquiry that you have, please put it at the description, at the comment section, so that I answer to you promptly. And please, for my new viewers, kindly subscribe to this channel, because you don't want to miss any of the upcoming video updates. Thank you very much. Stay tuned till we meet again in our next session. Bye bye.